really robust data of tens of thousands of people, 90+% of Americans, probably 99% of Americans are deficient in something. And the major deficiencies, about 90% are deficient or more in omega-3 fats, 50% in magnesium, probably, 20% in iron. Zinc is 40% deficient. So we've got these major deficiencies of these key nutrients that are really essential for biology. And what people don't understand about nutrition and nutrients is that they're pleomorphic. And that means in English that they have a lot of functions. So if you take a drug, let's say a statin, it basically has one action. It blocks this enzyme that produces cholesterol, HMG-CoA reductase. And it also has some other, we call pleiotropic effects. It also actually induces something called nitric oxide synthase, which is good for producing nitric oxide, which may reduce inflammation. But also has other side effects. It kind of blocks CoQ10 production because it's also the same enzyme, and it may cause muscle injury. But there's generally very few pathways. Nutrients, on the other hand, like magnesium, has 300 different enzymes that it regulates. Zinc, same thing, 200 different enzymes. So they have multiple functions throughout multiple parts of our cellular physiology that if we don't have them, it's like our cellular machinery can't do what it's supposed to do. And this was sort of mind-blowing when I first heard about it, Drew. Bruce Ames, one of the leading researchers in nutrition and science, there's a test called after him, the Ames test, to look for cancer-inducing compounds. And he's like probably in his late 80s now. He's still around. And he wrote an article years ago, which basically mapped out that 1/3 of our whole DNA, our entire DNA, codes for enzymes. Enzymes are basically catalysts that change one chemical to another chemical in your body to do what it's supposed to do. Well, if 1/3 of your entire DNA codes for enzymes, that's important. So what do enzymes need to work? They need coenzymes or cofactors, which are usually vitamins and minerals, but also phytonutrients. So how does enzymes work? Well, there's a little key that goes in the enzyme, it turns it on, and that key is usually a nutrient, vitamin C, B6, folate. In other words, for example, to make tryptophan into serotonin, which is your happy mood chemical, you take the amino acid you're eating from tryptophan, which comes from food like protein, turkey, everybody knows turkey, tryptophan, that has to get converted to serotonin. Well, that requires vitamin B6. There's an enzyme. Or your thyroid, in order to make the thyroid that your thyroid gland makes into the active thyroid hormone T3, you have an enzyme there, which actually requires selenium. So if you don't have selenium, it can't work. Or if you want to see the thyroid action on the nucleus, where it actually does all its work to controlling metabolism, you need vitamin D as a cofactor to help it function at the nuclear level to create the downstream effects, which is to turn on different genes to do different things. They regulate your metabolism and so many other things. So nutrients are such a critical part of our biology. And if we don't have enough of the required nutrients, our health degrades. And years ago, and I know this is a long answer to your question, but I'm on a roll here.
It's all great knowledge. I love it.
There's a scientist named Robert Heaney who recently died, who wrote an article called Long Latency Deficiency Diseases. So we all learned about vitamins. I mean, the vitamins we learned about only about 120 years ago. The term comes from vital amine. It's a thing that's needed for your health, for vitality, basically. And they were first discovered because they started refining grains in the 1800s, because the grain mill came up, and it was a great discovery that you could refine grains. And what happened was they took out all the nutrients that are in the husk and the fiber and the ectosperm, where all the vitamins and vitamin E and everything is in there, and all they left was the starch. And so they started feeding this refined grains to chickens, and the chickens all got really sick. And they started feeding it to prisoners, and the prisoners all got really sick. They got like beriberi and pellagra and all these horrible vitamin deficiency diseases. And they're terrible, like they're really terrible diseases. Scurvy, obviously is something people know about. And these will kill you or make you demented or turn your skin into like this whole raw mess just from little vitamin deficiency. And so that's what's the discovery of vitamins. And they realized that these were sort of things needed in very little amounts that had profound effects. I mean, imagine if there was a drug that cost pennies, that had no side effects, that literally worked in days to cure illness, I mean, that would be pretty amazing, but that's what vitamins do. If you take someone who's vitamin deficient and you give them a vitamin like vitamin C to someone who's got scurvy, it's like within a few days they're better and everything's gone. So, and even vitamin C, you think, oh, vitamin C, everybody's got vitamin C, but 10% of Americans are deficient in vitamin C at the level that would cause scurvy. This is no joke. So, long story short, one, our food supply has been hybridized to breed out nutrition. It's bred for starch and maybe a little protein, but not for nutrients. It's also grown in soils that have very little organic matter that can't extract the nutrients from the soil for the plant. So there are nutrients in the soil, but the plants need the microorganisms in the soil to actually, as symbiotic helpers, to extract the nutrients from the soil to go into the plant. So then it's in the plant, then you can eat it. But now maybe your broccoli today is 50% less nutritious than it was 50 years ago. So that's another problem. And then we have increased nutrient needs because we're under chronic stress, because we're exposed to environmental toxins. I mean, there were 80,000 new chemicals introduced into the marketplace since the 1900s. I mean, our bodies have to deal with all that stuff. And there's chemical reactions and detoxification, and they all require nutrients. And we are also under a tremendous amount of psychological stress, even in the society. And magnesium, your body wastes magnesium when you're under psychological stress. So there's so many things that are happening in our omega-3 fats. We don't get those because we don't really eat wild food anymore. Maybe some fish, but that's got mercury. So there's all these problems that happen because of our nutritional environment. And so more than ever now, people need foundational nutritional support. I believe that. And I say this not from a sort of a general opinion, but actually from really hard scientific data. And they go, oh, well, all the vitamin studies, they show that they don't prevent heart attacks, they don't prevent cancer, they don't do this, they don't do that, or they may have side effects. And the truth is, the studies are just all poorly designed. I mean, it's like, think about Michael Jordan, like arguably the best basketball player in history. If you put him on a court by himself, he could not win a single game, right?
Against another team that had a full team.
Yeah, right. So nutrients work as a team. And if you don't have all of them, your biochemistry kind of gets gummed up, and it can actually cause worse problems. So, for example, they did this large study called the CARROT study, where they gave smokers who were at high risk for lung cancer beta-carotene, because it seemed like people who ate fruits and vegetables with lots of beta-carotene actually did better. But when they actually gave the beta-carotene as a supplement, what happened was there was more cancer. Now, the science was like, oh, this is terrible, supplements don't work. I'm like, one, this is a perfect example of what Michael Pollan calls nutritionism, which is reductionism in nutrients, where you basically see, oh, it's maybe this single thing and we're going to just replace that. It doesn't work like that.
Which is how they think about drugs.
Drugs, right. So basically, the CARROT study gave high dose of beta-carotene. Now, if you actually understand basic biology and how antioxidants work in the system, they work as a team. So if you give one of them, the way they work is they donate an electron to some damaged tissue or free radical, like an oxidized compound in the body. So an antioxidant will actually help deal with oxidative stress or rusting in the body, but the way it does it is it donates one of its electrons. Then it becomes a radical. So, for example, vitamin C is a great antioxidant, but it'll donate one of its electrons, and then it becomes an ascorbyl radical, which is highly dangerous. But don't worry, then you got vitamin E to help take that electron from vitamin E and give it to the vitamin C, and it becomes a tocopherol radical. And then that has to be dealt with by all these systems like lipoic acid, and that then has to be dealt with by glutathione. So you've got a whole system. If you don't have all the antioxidants and you don't have the final pathways of glutathione, you're going to get in trouble. And so you're going to actually create more oxidative stress and more damage if you just give a high dose of a single nutrient like that.